model neurons, and I model how large number of neurons interact together, data coming from experiments, and these neurons are virtualized in terms of mathematical simulations. These simulations are very intense. For example, one of our simulations takes 20 terabytes of data in a day, chunks out 20 terabytes of data in a day. And if I put that into context, this is my inspiration for a virtual lab. So somebody asked about how to build complex things and build platform circuits. The Human Brain project in Europe is kind of interactive. So each dot in this space that I'm showing is one biophysically modeled neuron. So when we were doing this way back many years ago, we are still expanding on it. We only know a small microcube of, let's say, rat brains, sensorial inputs of cerebellum. And we started looking at different phenomena, and these platform of tools started coming up. So the question is that only for education, or is it only for research, or can we take it to beyond that? So that was one of the motivations that said, probably I need to spend a lot more time developing the right tools. I'm not going to talk about any of these simulations. Let me talk about something that more inspires me more. Specifically, a story that came 2 weeks or 3 weeks ago from some of my colleagues in the hospital. So Sandeep, who is one of the guy with glasses here, Dr. Sandeep's, reconstructed using a 3D infant model the sternum of a baby who didn't have a sternum. So that's Atmika, who's recovering from a surgery. So he used a 3D printer to study how the left 7th rib of the patient would be and use that to reconstruct a structure. So if you talk to him, he's a pure clinician. But if you look at the team, the work that they did, they realize that it's much more than one. So 3D printing is not a clinician's job. So you might actually see that education is now going transdisciplinary. And that's becoming critical, especially when it comes to critical in core sciences like this or in education. So 2009, approximately April, I think that's when Government of India decided that they should build a set of laboratories for India, for Indian students who do not have access to it, and to provide a complement to the NPTEL program. I mean, NPTEL was already running. And the complement was, how do I give expensive lab? I mean, I'll start with the ones that we didn't follow. The most expensive equipment that some institutions have, how can I put it online? That was the first question that the HRD minister and others wanted to ask this group of us sitting in front trying to write a proper proposal. They also asked us, how do you handle samples if you're across in 2 geographic domains? The third most important thing, how do you make the students understand the same practices across classrooms, across content classrooms? And this was the same goal with which we thought laboratory skilling is a very crucial crucial exercise, especially when you come into some of the aspects that others have addressed here. Trying to give perfect skills or usable, repeatable, reproducible skills. And India wanted not just IT but also manufacturing sector, electrical engineering sector, and other things. What I did at that time, we proposed why not also include some other forms of engineering, and we did. We shared, or the IIT shared. IIT Delhi, for example, took off electronics engineering. IIT Kharagpur did computer science. Amrita did biotechnology. It was a big challenge. So what our goals was, there were some labs on the web. For example, Europe is not behind. There was already a European project, an FP6 project called Leela, a library of labs. Judd Howard came from MIT. He had the iLab architecture. We had quite a few others, and today if you look it up, there are much more people doing it. What is a lab? So, but before I come to that, let me tell you, the project was officially launched several years ago. That was Kapil Sibal on February 26, 2012 or 23rd, 2012, launching the entire Virtual Labs collective. And we were, as I say, a big family of institutions doing lots of work together. And we don't consider any institution different. We just wanted to create 1,000 expensive labs in the beginning, but then we decided 1,000 usable labs as a better definition. So what is a virtual lab is a good question that will be answered very soon. Before that, let me tell you, this is not just for engineering. My colleagues in a group called Create at Amrita have been working on medical simulations platform. All this is openly, freely available. So if you Google MedSim, you will get it for free. What did it say? The MedSim challenge was an average medical student finds it very hard to kill a patient. I'm sorry, I'm using the term kill a patient to say to virtually kill a patient, which means in his mind to to create the paradigm, to test all possible paradigms. And we see that several students do not try out certain options just because they are scared about the concept. So we created virtual patients, and you can do what is called case-based studies, and these are all free. You can Google it online. And this group is very interesting. They didn't stop with medicine, they did for 14,600 CBSE schools in India, they are online labs. The O Labs Collective is also by the same group, Prema group. In fact, last year in September, they started testing their English learning app in the non-English speaking parts of the US. And this year in March, we got the $7 million Barbara Bush X Prize Award. So this is Prema collecting it from Dora Bush, Senior George Bush's daughter. So Bush Foundation was testing how free learning apps can change learning environments for adult learners, and this was one of the examples with which I can tell you ICT is kind of crucial to change the way we think today. So all these questions to come back. So what is a virtual lab? So when we started virtual labs, we thought virtual lab is a laboratory that is done on a computer. Great definition, perfect. Government of India wanted a few additions to it. It said the lab should be part of a curriculum, it should be part of a course, and X number of experiments should make a laboratory course. So the first definition of the virtual lab was a laboratory course, and the next definition was a laboratory course has several virtual labs. So we used a little bit of, we mixed terminologies, but at the end, and I'm talking about a very small subset. All this is free. If you go to vlab.amrita.edu, and if you have a Google account, you can log in, you can perform the experiments online. I just have to tell you, we turned off the remotely controlled labs. I'll come to it very soon. So what did we do? We tried creating a standalone independent content where a remote student or a socially challenged student could go to a computer terminal and learn from a laboratory, from the virtual lab website, all the content without buying a book, which was kind of important for India. Developing our own content was very crucial. So how can you create the laboratory content that was yours own? So if you go to vlab.co.in, this is the actual website of the main project, or to vlab.amrita.edu, you can find all these resources for free.
Can I ask?
Yes, please.
Is every lab in the virtual lab based has the core as a simulation model?
Okay, so
because I mean, and the second question then is there a common framework for defining simulation models within virtual labs? That's the
fabulous. So I'll answer both these questions very well. First thing, we define three kinds of labs. I'm coming to it very quickly, but before we developed lab, we realized that it was not just important to put the content. There are a majority of the students who wouldn't have, if you have a speaker like a MOOC-like phenomena or an NPTEL-like phenomena where a person would explain the philosophy of it without the person. Of course, we developed animations for that. We developed content, video content, small video contents, 4 to 5 minute videos, because we found that the average attention span for a student performing a virtual lab in a 2-hour lab course was no more than 4 minutes to 5 minutes. So we put 4 or 5 minute core content as a video, and it's expensive to develop. So anybody who's having a school like this will tell you creating good video, animation-based videos or videos are not cheap. We also did, we'll come to the types of it, but this is just an example of saying these are the labs that Amrita has developed, and my particular work was related to the first domain, the biotechnology and biomedical engineering, for which we also led the countries as a coordination process. One of the things we needed for a virtual lab was LMS, and we had to develop it from scratch. We didn't use Moodle, we used a simplified LMS. We call it the Collaboration and Accessibility Platform, because we thought in teachers interacting, students interacting, and these kind of ability to post questions were very critical. So we built a system like this that would schedule your experiments, that would answer some of your questions to your experiments. Now we'll come to the type of the question that you asked me. So we tried as a group, as a consortium, we realized that engineering has some experiments that can be simulated, some experiments that cannot be simulated, and in biology you have a majority of experiments that cannot be simulated because of complexity, and you can only animate them. So we did what is called an emulation, a laboratory emulation. So we did 3 types of experiments. One, where a student or a teacher cannot repeat whatever he does in a classroom, we could emulate the environment of the classroom in the process. Where I can show you examples like opening up, brain slicing experiment. A brain slicing experiment requires things that cannot be done on a simulator. But a brain slicing is critical if you want to do the next step, which is patch clamping or voltage clamping. And that you can do it in a mathematical simulator. So there are a bunch of experiments that can be mathematically simulated. Most of first year undergraduate physics or chemistry, we could simulate it with basic math. And most of our simulators were running on a browser, not on a browsing server-based system, but on a remote browser. So the idea is, if you have a device and some connectivity, you should be able to run it on a local browser. The third one that we did was a very expensive exercise called the remotely controlled experiment, remotely triggered experiments. So what we did is we took a scanning electron microscope, we took 2 photon microscopes, IIT Delhi did a SEM, some of us did, there was one Agile spectral analyzer, there was some expensive bioreactor, that in fact in Pune, the person who was supposed to be here, Sudhir Agache, built an entire laboratory built of just equipment that can be triggered from remote. So we did some of that as well. So these 3 types of experiments is what we decided. Initially, we thought remote trigger was a great choice because people collect real data. But we didn't do remotely triggered equipment, we did remotely triggered experiments. That was not feasible. We could only trigger an equipment in a set in a particular configuration, given the numbers that later, Government of India decided that scalability was an issue and said only animations and mathematical simulations. So you can see this one was a robotic arm that was done by a student who wanted to teach 3DOF dynamic Hardenberg parameters, how to classify left or right movement using DH transformation. This was an experiment where we did how to dissect parts of we did a couple of animals, but mainly rats, typically for immunosciences. And finally, for example, we did 2 courses of pure mathematical simulations only on what is called population dynamics, changes in populations across species. So it's part of the ecology course that we teach. We call it population ecology, and there are approximately 14 experiments that are basically running on HTML5 right now, JavaScript HTML5, basically running the same simulation. So where you could do small simulations that would teach a lot of content, but not much. It's not like simulating the entire brain or realistic circuits. We did different architectures. We could with the remotely controlled lab, the first thing that we experienced is students, especially good students from computer science, would shut us down for some time. The moment we are up, somebody would hack into the server, get into the code, and shut us down. So we had to build an architecture for the server controls mechanism that would anonymize a lot of the controls and limit the student's ability to break the system. Especially if you have a ball and a pendulum, let's say a complex pendulum, all you have to do is change the speed of the pendulum and your device will break. So we didn't have sustainability there. So we had to build a system that would take a teacher's feedback based on the configurations that you try in a lab and control whatever interfaces that you have. So I'm going to go a little faster on some slides, which I don't think is critical, which everybody knows here. We found that biology students, most of our biology students, not just ours, I'm talking the Amrita platform alone has 347,000 online users right now. And I'll talk about another program that we started 5 years ago that connects teachers and students together as a community. In that 347,000 users, we found a large number of biology students were very unhappy with simulations, mathematical simulations. When the simulator has numbers, I don't come to visit. So you can see Google Analytics telling you that no more than 3 seconds on the page. So you come, go next page. And they'll see what answers they want to generate, that's all. Whereas engineers, on the other hand, have a very different approach. We saw engineering students, especially there's a college in Bangalore called BMS, which is a nodal center with us. And BMS basically sends out this, has this first year undergraduate students who actually do a lot of this for, let's say, at least a 19-minute or 15-minute stretches together. So 16 minutes to 19 minutes was the average time an engineering student would spend on a single experiment. This was great data for us. We realized after developing a first set of labs that when you develop content, the goals of most learners, remote learners or blended learners in a classroom are quite different from the models that we have. So you may have to challenge yourself and say, that's where I find the challenge when you have a MOOC and you want to integrate a MOOC, a virtual lab into a MOOC, probably you might have to redesign the entire virtual lab. So that's the kind of problem that we were facing when government asked us, can you club NPTEL and MOOC and NPTEL and virtual labs? And I think there's only one success story till now. one in a mechanical engineering or dynamics lab, I think. We also found that most of the time, classroom skills and laboratory skills do not complement each other. A student who actually performs really well in classrooms do not necessarily complement the same skill set, do not showcase the same skill set when it comes to a lab, and that's not unusual. We are talking about not just theoreticians, biologists and theoreticians, we are also talking about skilling related sciences, and we have seen that with skilling programs like carpentry, we have seen that with skilling programs like plumbing, and that's a whole new project that I wouldn't talk about right now, but this is happening. So classroom knowledge and laboratory skill set have different course outcomes or course designs. So we may have to rethink how to integrate these kind of platforms together. So a few years ago, we started conducting, not few years, I think 8 years ago, we started conducting several workshops where we invite faculty members and students from different institutions, sitting together and asking them, we tested different things. We tried hole in the wall kind of an experiment where we didn't allow any teaching to the teacher or the student, said please go start using your platform and tell us what happens. And I'm going to tell you what we did. One of the things that we couldn't sustain was a continued usage. So in 2011, we decided that we needed to launch a different way of thinking to keep ICT-based tools in classroom education. And we called it the Nodal Center program. Today we have, these are just statistics, so we have 111 Nodal Centers today. We have done around 324 workshops for teachers and students, and around 16,800 teachers trained, that's Amrita numbers alone. If you take the national numbers, it will be much bigger. And approximately, let's say, 250, 60,000 students who are regularly using it, trained through our workshops. And we are talking about the numbers that I have. We have, on the Amrita platform, we had 360 experiments, online experiments and so on. And these are our nodal centers, some of our institutions that work with it. So what was this Nodal Center program? Nodal Center program was getting a person to champion your course in another institution. And that helps ICT education a lot, completely changes the numbers. So we had one professor say from Sri Ramakrishna Engineering College or from BMS would come and say, let me make sure that all my students go through this program and I'll make it as a component in my lab. Can you give us a Nodal Center recognition? And MHRD would say, please send us a list of who's working with whom. So we would send that, and AICT appreciated it. AICT and MHRD, Ministry of HRD and AICT is the organization that recognizes engineering institutions, for those who do not know that, have been trying to say, give us a marker and say who's using what. So we started looking at how these usages change over time. I'm going to throw away these numbers and come to much more studies that we did. So one curious answer is, even if you develop online tools or MOOCs, effectiveness of usages or effectiveness of the outcomes of your course seems to be, in laboratory courses at least, seems to be on your personal effort to put an outreach. So that's why I love NPTEL. NPTEL has a huge outreach. And probably it's the one thing that would help anybody to tie up with any other learning programs. If you look at education, in India you will see during exams times the usage goes up very high. And overnight at 10 p.m. or 11 p.m. at night, we get emails. I need the answer to the following question. They use the discussion forum to check out answers, which is very common. So you know that your platform is being used even when you get, let's say, 15,000 emails, which is fine, which is still fine. So now I'll come to a few studies that I wanted to talk. I'm very happy that Gabriela already talked about several things about what we tested. So early years, we tested the virtual labs as a concept of, can I replace the learning textbook? Can I complement virtual labs? So my questions were very different. My questions were, does virtual lab have, will you have to do virtual labs before your real lab or virtual labs after your real lab? What difference does it make? So for a student who doesn't have a laboratory, what is virtual lab changing? So some of these questions we started asking using very simple studies. So most of these papers are published. I think if you Google me or Google the virtual lab site, there's a publication page. We found out through, let's say, 700 teachers in workshops in Tamil Nadu and a little bit of Kerala, that many teachers in remote institutions meaning not the top tier institutions, they prefer a hybrid approach, which means that they prefer virtual labs as a teaching platform. So they don't want to use it as a complement to their laboratory exercise because they were concerned. But we also saw that most of the students who took a virtual lab, there was one candidate that was very inspiring. I think 2010, he failed in 7 subjects. That was my first case to start the study. He failed in 7 subjects and he never graduated his master's program. He took virtual lab-based exams given as teacher and he showed that he graduated the next semester. So maybe it's the 8th attempt, maybe it's probably the virtual labs. We do not know, but we found out through our questionnaires that virtual labs started improving classroom education. I'm not going to go into some of these things, but I'll tell you that we tried the college learning phenomena when we started evaluating whether people who use virtual labs or learning platforms, what kind of learners would they recommend. Most of them were assimilators. As you know, in college phenomena, assimilators are good at understanding the problem in a logical form. So if logic was there, we asked the question, can they do problem solving? Can they bring in a translation of the effort? Can they do divergent thinking? And we found that assimilators, most of the virtual lab students categorize themselves as assimilators, or they could solve certain questions that were critical to their understanding or to their requirement of understanding. We also looked at reflective observation. We'll come to it very soon. We substituted classroom presentations and we substituted virtual labs. So we tested how does virtual lab, do students perform better if you introduce virtual lab before they go into a real lab or after? And we found out that the difference is very little. They do definitely the format which is most optimal for biotechnology was to present virtual labs as a pre-lab exercise, not as a post-lab exercise. Post-lab, they made a very small change. Pre-lab, they made a huge change. So that's why I'm going to try to tell you. Some of that are in papers. We also recognize that concepts that people are scared of, especially in using equipment, people change that. So you can build online labs, you can build online tools, you can ask them questions that will say, how can you look at, if you're looking at Thomas Kuhn's style of phenomena, can you look at, can you pose a set of questions and test the set of questions without changing the environment, but just by making them work in an environment which is ICT fuel or ICT blended. Many people said if they familiarize concepts, some of them said they train on the topics that are related to class, and few said through the process we also learn new concepts. So virtual labs seem to be also appropriate for distance education, which means that probably if you want to scale up a course and you're considering this many large number of students, going online is still a great idea if you complement a few set of skills, but there are limitations in developing some labs. I maybe address it a little later. We also did look at remote labs. Remote labs are those labs that where equipment was remote and we wanted to trigger them. And we found out that most people would say it's easy to control. That's because most of the things, if you ask me, photovoltaic, a simple experiment in first year of almost bachelor's in physics or engineering is to determine the P versus V or I versus V relationship on photovoltaic or a panel. People would say, oh, that's already pre-configured, I can test it. So maybe we thought there was some component missing because it probably we pre-configured them too much. So we started testing the same question on a microscope. A microscope, the sample is available but they do not know where to search. So we asked them to count the number of cells inside a microscope and then we found similar results. So we said probably there are commonness in remotely triggered equipment, but remotely triggered equipment is expensive to maintain, it's not sustainable. At least for a country that's planning a large usage, we are talking about minimum of 5,000 usages per week, which is 5,000 people logging in at least once. And that was a tough number for us to manage. We had 40,000 usages on an average during the week in the in the teaching period. So for example, August to September, we might get 40,000 usages a week. So if you put in all this together, we did two specific studies. One was we looked at augmented reflective learning. Reflective learning is the ability of the student to apply a known topic in an unknown environment. So we tested 3 phenomena. We created a questionnaire called the MAT questionnaire: metacognition, analogical reasoning, and transfer of knowledge. So this is a bunch of questions that we asked the student, not about the experiment alone, about a lot of things. And this MAT questionnaire is what we use in testing whether the student can do what happens to the virtual lab under different usages. And we found for physics students, we couldn't do it with a higher education. We did it with undergraduate physics first year. All engineering students do 1 year of under one physics program. So we tested how is their logical thinking affected to these kind of, and we found out that students adapt. So if in the tests that we had a control condition where the students go to the regular classroom. We also test what is called CVP and CPV. CVP means I did control first, which is only the lab, standard lab, virtual labs next, then the physical laboratory, the real lab that students have to do. We also did the opposite. We did the physical lab and virtual lab. I told you about it. The changes are minimal, but the changes that if a student improvement is considered, adding virtual lab component changes students' understanding. If you talk to Brandeis University, they have a TILT, I think a center called TILT, where Milady Ann Winkles is now talking about how professors can reduce the time that they need to spend to teach, tell students how the course is important. She says that there are only 3 things that you need to add. Purpose, PIC, criterion, I don't remember the center one. So purpose, so before the course starts, all the professor has to do is put up those 3. So we think virtual lab is basically a combination of those 3 parameters. But we also did that in chemistry classroom. So we wanted in chemistry, typically, most engineers, most of our undergraduate engineers, when they come into chemistry classroom, they always do not want to learn chemistry, thinking that it's not a part that they do. Usually they want to do computer sciences or electronics engineering or mechanical engineering and not necessarily chemical engineering. So except chemical engineering, we tested how would chemistry students do it. And we found out that with PG students, we did a traditional, we created what is called, typically when you have this bonding, very simple experiment, asymmetry and bonding, people always get it wrong. So we did a test on, this is part of, these last 2 papers are part of what is called EA, Education and IT, Springer Journal. So if you Google up, you'll get it. And it's both led by Krishna Sriachalan, who was our lead study in both the cases. And 3 of us worked together in both papers, Sanish and Vishal switching in between. So we found alternate conceptions in certain labs, certain theoretical classrooms were changed by virtual labs. So you can integrate certain phenomena and say, so the goal that we wanted to see is where do students go wrong? Most of the virtual labs, I have to be honest, we designed it on the success of the students, the learning outcome. We never develop a virtual lab that teaches them how to fail. How to fail to do an experiment. And that's a major exercise that virtual labs in the future may have to do, or data-driven virtual labs will have to do. In fact, right now we are doing 2 virtual, to answer your second, we are doing 2 new virtual labs that are based on Python platform and R. So we are launching R for Bioinformatics, Data Science Lab and a Biosignal Processing Lab, both for students based on just browsers, but we are using Python, and where the student actually has to send in snippets of code. Only problem that you have to do it, if you do it, you have to design each lab as a course module. So we found that most of our students do not respond if your content is just a page. Just to give you a brief preview, let me show you how it looks like. I think, okay, I have something that says extending duplicate my screen. Yeah, so most of the experiments, unfortunately I'm using Microsoft Edge because I don't have Flash on my. So if you go to, if you go to our virtual lab website, which is the Amrita Virtual Lab or the other one, we allow people to log in using, can be Google, Yahoo, institutional ID, whatever that they want to. So if they go into a lab, they have into a domain, they have different topics. Each of these highlighted topic is a lab by definition. And these definitions, so you can click on the lab, and each lab, for example, will have a content. A virtual lab for us was an integrated learning experience. So we created theory, a procedure tab. A self-evaluation is like a quiz that comes before the experiment is done. Animation, where animations are possible. Simulations, where simulations are possible. Animation and simulation, sometimes when both are possible. We also did emulations, we call them simulations. Basically, we emulated certain results by creating combinations. And we also did remote trigger, so you can see remote control or remote trigger panel. And we have an assignment tab and a reference tab. If you look at most of the undergraduate or postgraduate syllabus, we developed a content in a small video, like I said. If you look at, let me see. So if you look at this, agarose gel electrophoresis, which is a molecular bio. Most of these were done in 2009, 2010, 2011. So some of these interfaces need refreshing. So what we try to do is to recreate some of these. This is an animation as it is. We found out that when students would not interact with an animation, they tended, at least our students, I'm talking about 6,000 students that we recorded at that time. 6,000 students would say that you need explicit user interaction to pursue the study. So if your page doesn't have anything to click, they say next, I want to go come back later. If it is too much like a movie, they don't work with you either. So we started looking at animations that were non-clickable with very minor clicks, but we created emulations so you can navigate. So we created some navigation for those people who already knew it, they could navigate it. We had a list where you can even switch to it. So if you come to this, you will see that. And to get to this answer, we also created what is called a test yourself kind of scenario. So I'm sorry, it's asking me to log in, which means that I should have, yeah. I use my Google ID, which is much easier. Or you can register and log in, so it's fine. So if you do that, you will have a simulator. I mean, students, usually learners, have a simulator for them. We didn't design the simulator or the animation only for students. We thought it was an easy way to make sure teaching load is reduced. In fact, the maximal users of our virtual labs in the early years were teachers using it in classrooms to reduce their teaching time. So if you look at compound pendulum, RC circuits, RLC circuits that we teach typically, here you can do it, it's all animated and you can do it in a few seconds and you can test your output. And this is mathematically simulated as well. So you can, for a biology student, testing out things that would be expensive was an idea that we thought was very, very critical. So we did, I'm sorry, some things, yeah. So if I use common enzymes and I ask them to do, let's say, identify as agarose gel plate, you can say that what we wanted to deliver to the student was a time, not necessarily the time, but seemingly real feel of what the time would be, or what the time, so we turned on, yeah, you can see that the thing goes down. That was an animation. We timed it with a simulator loop, but this is not a real mathematical simulation. This is what we call as an emulation. Why was this necessary? Because this is a common first year experiment. So when you teach this on a classroom, average lab teaching time was 3 hours of spending our teacher standing in front. In virtual labs, it was 16.5 minutes, 17 minutes approximately. So you did see some changes, and let me turn it off. Then I mean, basically students would do this and they would get a agarose gel plate and they say, this is my plate, and they show a teacher and they get a first year signature or first year approval. This is what they have to do, and this is how they do a lot of tests also in the future. So we design our labs also to fit another set of curriculum. Many of our experiments, if you bundle them together, they create one entire experiment in larger domains. So that was a way to keep my questions about incentivizing and all these questions that I asked is because we found that online forums, for example, was an incentive. When we created the back panel for this virtual lab platform and a teacher would come up, we created in such a way that at that time we didn't use Moodle, so we allowed students to assign a teacher. So if a class teacher goes and says, look, I'm on virtual lab platform, this is my ID, I'm going to give you an assignment, only if you add me as your teacher can I send you the assignment. So this was an opposite way of trying to get the student community involved in getting to choose what they want to be taught or whom their instructor is. And when it's remote, this doesn't come as a choice. So what happens is, many of the teachers who took up these kind of classrooms started receiving also remote students, and they would compare how their students fared against remote students. And these were certain things that were very powerful. So coming back, I think I'm almost at the end, but I can ask questions. But we are, since last October or November, one of our biggest challenges is Ministry of HRD asked us, can you tie your virtual labs into the NPTEL program? And that's very common. That was a very nice question that we asked. And I still remember we asked, saying the learning objectives and the course outcomes were not designed for virtual labs to be integrated, so how should we do it? In fact, NPTEL also had a similar issue. They were designed much earlier than the virtual labs. So the course content could not necessarily be, but we are striving to do it. So if the design, wherever the lab's content matches the design, for example, there is a electrical machines lab built by Teresa, based on one of the books by Teresa. I think that content has a lot of common things that you can do. It is a complete no. It was if the lab was independently designed as a standalone. So if there's an exercise that we want to do as a next MIELES or next extension, a bigger challenge would be to develop new labs or new exercises that would match existing textual content. It might be easier to go with the classroom content that we have in NPTEL and create a new lab.
Okay, I have a question about the development. I mean, if you have an existing course, and then in a case like you have a normal set of physical setups that are in the lab sometimes. So what does the teacher do? I mean, who would do the development? I mean, could a teacher come and say, oh, I have this course, and I have this physical setup, which is the lab situation, and I have a description of what normally happens, and go with that description to some of your team, and then it's discussed how it should be implemented. So how does it work?
Okay. So I'm smiling at myself because this is a question that we've been trying to answer. And most of the, in our cases, the virtual labs or NPTEL, most of our faculty members were shared. So people who did courses, NPTEL courses, were also developing certain labs in some of them. And some others who developed labs also did NPTEL courses in the past. So for example, this was my first year giving a lecture on NPTEL for the first time. I've given one module as a guest lecture in one of the IIT Madras courses. That's on neuroscience, neuromechanics actually. So what I learned is that the content there is to help students graduate, answer the right questions, get some learning. And if you want to develop a lab that matches that, it's either...
Maybe I have to rephrase my question. So consider that I know exactly what I want as a teacher, but I only have a conceptual design on whatever. Is every implementation of a virtual lab that it realize my design, the unique software production, independent
Yes.
of any other virtual lab?
Yes.
So somebody sits down and say, okay, because your lab has your thought and your conceptual scheme for your lab has these properties, we have to do like this, either we make a simulation model, or we make a planning model, or a remote staging, or on media production, or whatever, and it's a unique choice.
Absolutely.
For every setup.
So
and you need a little, very qualified software team.
Very simple. So
to do it, actually.
Yeah.
Wait, is that true?
It's true, it's true. I mean, the way we have done this project at least is that you go to GitHub, you download our code, you can change it if you want to. If it's a lab that is ordered, most of our labs are standalone exercises. So basically it's like the exercise page of your book. We call the virtual labs as interactive textbooks of the future. We don't call them as lab replacements.
Yeah. That is my question. So what I understood from you is that virtual labs were designed not with online courses in mind.
Absolutely. In the past, yes.
It's an aid for the teacher, so either to simplify the labs, or in the cases where lab facilities were expensive or not there, to compensate for that lack of facility. So that's what originally was designed.
Absolutely.
Okay. So then the next challenge is that how virtual labs can be incorporated in online type of courses. So for that, because there was a learning outcome for each course, then one may need data specifically, as Kelly was asking, specifically for that new labs.
So what we did, to answer that, I understood the question, it's just that what we did was when we started working on these projects, we didn't do them together, so we are independent staff. But each lab was an independent module, which means that even when a person developed a lab, you would deploy these questions, you would deploy each lab independently on a browser. This is a national website, and what we did as an exercise 2 years ago, or 3 years ago maybe, is that we mapped all the available labs that we had to wherever NPTEL had courses, and we mapped it. So when we found an NPTEL course, we don't know about the latest NPTEL courses, I'm talking about maybe they updated it, there's a team doing it. So we found these labs, so for example, data mining lab. So if I'm doing a data mining lab and you have ANNs, some form of ANNs there, say you want to do a pattern classification problem in the ANM, you would map the data mining lab directly, that experiment of the data mining lab to the point where your MOOC talks about that exercise. So that kind of a mapping was possible. What we did was a mapping saying, NPTEL has this course, this lab might be appropriate for that course. That's all what we did. That's all we could do because that was not part of the project, initially thought project. Right now, we feel that any course that you have to develop would be nice to have an interactive component. Like, for example, Coursera has that GPU program course where they give you a terminal and say run the code. So you have to write a piece of code, run the code as part of the exercise. So you learn scripting code during the Coursera MOOC. So that's an idea that has been there in our minds for a long time, but we didn't the labs are complementary to the virtual labs and not.
And I mean, also, just to follow up, this is very, very practical question. So either happen to be a virtual lab existing that happen to match my needs, and then it's more a question: how can I refer to it? I mean, it's a more administrative. How do I get it into the course practice? So the other case is that it doesn't exist any match. So then, if I have the non-trivial physical setup, I need to set up a software development project.
Yes.
And MPTEL, for example, have no resources for that at that point. So it must be an independent project, must be funded somehow. But could somebody go to virtual labs project and say, could you support that somehow? Or I mean it's very practical.
So first part of the question, if there's a existing content, to map to the content and modify the content could also be done. But we don't have, the same question, we don't have resources. We didn't earmark that component into any of our projects. So the virtual labs mission would tell you, all my collaborators, all of us standing here, would tell you that we don't have funds for that. The second part of the question is, if you want a new content, what we did a very non-trivial exercise. So we went to several institutions that were nodal centers, and we found that students are very talented. So what they do as their thesis project is usually when you give them a challenge that is worthy, they can develop the content for you. So you just have to do it the way. So Google Summer of Code does that in India and it's very successful. And GSAC is the same style that ICPC, GSAC, Virtual Lab is trying to do that. There is a bunch of, let's say, 10 or 12 institutions that have actually developed their own virtual labs free of cost. They used our platform to launch them, to host them, but the content was developed by the students or by staff. So yes, if you launch it as a competition, launch it as a thesis internship phenomenon that is remote internship, we can get it done. There are more. India is a country of possibilities. You can just have to channel the possibilities and look at it from how you want to pitch the problem. So you can definitely do it. And I think seeing the kind of painted work, you can even go for complex stuff. We are very interested with HPP, Human Brain Project. We are interested that after 2020, we want to see whether we can scale large data set, analyzing large data as a virtual lab issue, because at the end of it, all models are anyway virtual labs. So these are questions that we would like to ask, but we can ask this in different modules. So you can develop your own lab. You can ask a group of people who are connected to you, to see if we can explore the developing labs for you and then acknowledge them. Most of our virtual labs is Creative Commons NC, CC and CSA. So basically it's pretty easy for them to show, I developed this is CC and CSA, it's available for free. You can download it, reuse it, whatever you want. And we even have put all the source code in GitHub, so putting our Git is not a big deal and modifying it. Some students are so talented. I still remember last night, this morning, I left at 3:30 a.m. from Trivandrum. So 3 o'clock, my student comes and knocks and says, "You are up to, I wanted to show you that I developed a GUI for the biosignal analysis." It took 3 or 4 hours to remodel something that he found with the platform. So there is a possibility that we can work out some of this without the complexity of funding and other phenomena if it is a smaller case. If it's something that can be packaged, like for our dual masters or something like that, you can always think about that, and that could be one of the sidelines with which we can design outcomes. So course outcomes can happen. It's very easy. So it's not a problem of money. I would say India does not suffer the problem of money. It just suffers how to use the money appropriately. I think the question is, we have problems, we are trying to find solutions to it, and it's very easy to find it. We just have to put that in a motivational tone for the students. And we are doing it. For cybersecurity, that's the only way we are progressing. We have a malware detection system that is basically running that was actually started as a virtual platform to study malware with WHO in Amsterdam, but we ended up making it. Students ended up making it themselves. So it's now being projected as a full entire system. Sorry.
You are my ignorance about equipment and budget. So when you are developing a virtual lab, devoid of this particular program, then you would possibly have all the parameters of that equipment available. You will play a program.
Yes. You mean the experiments that we developed as part of virtual labs? The
What are the
equipment.
parameters of that machine?
So
in each case, why is it difficult to take it into another? When I create a program, I will probably need 3 or 4 of those parameters to be changed.
correct.
Why is it that I'm not able to take it in my
No, no,
am I getting it?
no. The thing is, it's not that we're not talking about that. I'm talking about experiments. Suppose, let's say, I'm talking about their courses, which I only knew them when we went in Barcelona a couple of months ago. So there, after that, when I Googled back, because I know Carl's work has been also used by some of our students. So the book and the content that the content that you used to have in. So when people ask us, the question is that not about what we wanted was, can we take a available NPTEL course like this, take a lab that is already available that was designed to curriculum, can I just not insert it inside? That's not possible because most of the labs were done by professors to answer to the laboratory courses in the universities. So remember, in India, you have 6+2 programs, so 6 courses are theory courses and 2 courses are labs.
Which means the virtual labs have assumed those courses.
We mapped it to the curriculum, undergraduate curriculum of AICT. So most of the experiment, so the idea was,
It's not actually devoid of the course.
no, it is, it's curriculum based. So it's curriculum based. And the idea was we would have 6 to 8 experiments per big university. So for example, I remember I had to match with VTU, Vishweshwara Technology University, Anna University, all these. So I had to tell where my course would be available, laboratory course. So it would match the laboratory. Unlike the integrated program where we are talking about an NPTEL course, borrowing components from the lab, which is different. So we would love to do the same. We would love to embed an entire course right into our virtual lab and say, this is a MOOC video from an NPTEL course, listen to it before you take the lab. But that's not possible because the course was designed that curriculum in focus. But we can, yes.
In a way, that's a good feature. I mean, the fragments are so you can take the
Yes.
piece from an MPTEL course and use it somewhere else. It's fine now.
Exactly.
So that's possible.
Also the vice versa, you can take a virtual lab and put it inside an NPTEL website.
You can just make a link.
Yeah. We are, that's the difficult question is, we want the questions that are asked by the teacher inside the NPTEL course to be answered by our virtual lab platform. That we are not able to map. Because we didn't consider those.
Maybe it may not be.
No, we have been trying as an exercise. Most of the faculty members who developed it, they move on. So this is 10 years old.
But just a follow-up.
Yes, please.
Because I think we are interested in seeing possibilities. So I mean, but you cannot. There is no real methodology from your side. I mean, so there is this teacher who has this idea conceptually of this lab, but have no clue about the realization. So that teacher needs help to implement the lab. But that teacher cannot go to you and say, can I get some methodological help in analyzing the problem at least? So, I mean, or...
Yes, in fact, we learned this process by building labs. 8 or 10 labs are entirely my content, my classroom content, which we translated into virtual lab. So in that process, we had to learn through the ontology, we had to learn through the pedagogy, the different delivery methods. We had to also look at, we had to be very careful where students do not use, for example. But one of the bad things, one of the negative things that we did, we spent a lot of hours building these colorful flash animations. Thanks to Apple, we had to say bye-bye to them. Now we can run it only on Microsoft Edge. But we converted, let's say, 20 into 8, 160 labs.